Hi everybody. Today I'm going to be teaching you lesson 12-2, which is arithmetic sequences. So we're going to start with a warm-up today. Take a minute to read through the warm-up, pause the video, and try to answer the warm-up question. Okay, so let's try to go over the warm-up question. Consider an arithmetic sequence whose first three terms are given by 4, 14, 24. What's the fourth term? So you want to try to figure out what the pattern is. In other words, how do you get from 4 to 14 and how do you get from 14 to 24? So with an arithmetic sequence we talked a little bit about yesterday, there is an adding pattern or there's a common difference between terms. So if you look at 4 and 14, you want to think about 4 plus what would equal 14. So you should see that you would need to add 10. And then you can test it going from 14 to 24. So 14 plus what would give me 24? Again, add 10. So 24 plus 10 would give me my next term, which would be 34. Let's take a look at part B. How many times was 10 added to 4 to get to the fourth term? Well, let's see. 10 was added 1, 2, 3 times. Part C, how can we apply what we learned in part A and B to find the 14th term? So if you were looking to find the 14th term, you could continue the pattern out until you got to the 14th term, but that would take a long time. So we could do that. Let's do that first. So we need 14 spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we started with 4, and then we were adding 10, and we got 14, 24, 34, 44, 54, 64, 74, 84, 94, 104, 114, 124, 134. So we know that the value of the 14th term, here's my 14th term, is 134. But that took a long time to do. So there's actually a quicker way to figure it out. So we want to think about how many times did we add 10 to get to the 14th term. So let's see. So we added 10, we added 10, we added 10, 10, 10, 10, 10, 10, 10, 94 to 104, we added 10, added 10, added 10, and added 10. So let's say we added 10 how many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times. So we added 10 13 times. So adding 10 13 times is really equal to 10 times 13. So we added 10 one less time than the number term we were looking for, right? So we added 10 13 times, we were looking for the 14th term. That should make sense to you because if we go back up to part A, we added 10 3 times, 1, 2, 3, when we were looking for the fourth term, okay? But if you multiply 10 times 13, it doesn't give you the answer 134. So you have to think to yourself, well, wait a minute. That gives me 130, right? 10 times 13. So how could I get to 134, which we know is the value of the 14th term? So you should realize that 134 is really 4 more than 130. So in order to find the 14th term, what you want to think about is taking your first term, which is a 4 in our case, and adding the 10 times 13. The reason why we're multiplying 10 times 13 again is because we added 10 13 times in order to find our 14th term. So there's a formula for an arithmetic sequence. It's called the explicit formula because you can use it to find any term in your sequence. And the formula is on your reference table. So you might want to just notate that here. It's on your reference sheet. So this is not a formula that you need to memorize. You'll be given this formula for all tests and the Regents exam. Okay. So let's take a look at what each part means. I'm going to start with a sub 1. So a sub 1 here means your first term. Your n value is the number of terms. Your d value is the common difference between terms, and your a sub n is your total value. Okay. So let's take a look at example 1. The first thing that you want to do is identify the common difference. So you want to think about what would you have to add to -2 in order to get to -8. So -2 plus what equals -8. And if you weren't sure, on the side of your paper, you could set up a little equation and say -2 plus something equals -8. I want to figure out what that something is. So you could solve this equation and say, okay, that something is -6. Or you could just look at the pattern and say, okay, I think it's -6, and then test it out. -8 plus -6, is that -14? And it is. Or again, you could set up a little equation. -8 plus something equals -14. And you should get that something is -6. Same thing would occur here. If you said -14 plus something is -20, if you were to solve, that something would be -6. So the common difference here is -6. That's the number that I'd be adding from the first term to the first term to get to the second term to get to the third term, or third term to get to the fourth term, and so on. Okay, so now I need to write an equation to represent this sequence. So I'm going to use this formula, a sub n equals a sub 1 plus n minus 1 times d. So the first thing I need to know is my first term. So can I figure out what my first term is? So I'm going to look at my sequence and say, okay, here's my first term, -2. So my a sub 1 is going to be equal to a -2. Can I figure out the common difference? Well, we figured out the common difference already was -6. That's how much we have to add from the first term to get to the second term to get to the third term, and so on. The thing that we don't know is n. We don't know how many terms we have in the sequence. We're just going to leave that as the variable n for now. So now I'm going to plug into my equation. So I have a sub n equals -2 plus, in parentheses, n minus 1 times -6. It's important to put that -6 in parentheses because you don't want it to look like subtraction. So if you had done this, this looks like you're subtracting 6, when really you mean that you want to multiply by -6. So just be careful about that. Okay, so you can leave your equation like that, or you can multiply it out and express it in standard form. So if you had multiplied it out, you would be multiplying the negative 6 times n to get negative 6n, and the negative 6 times negative 1 to get a positive 6. And then you could combine your like terms. So a sub n equals negative 6n, and I combine my negative 2 and my 6, I would get plus 4. So you could either leave your equation like this, where you multiplied out, or if you wanted to, you could leave your equation like we originally wrote it without multiplying out. Okay. Why is it useful to have an equation for the sequence? Well, let's go back to the do now for a second. You know, when we wanted to find the 14th term, we started by listing out all the terms and counting up to the 14th term. We can do that for 14 terms because it's not that high. But let's say we wanted to find the 120th term. That would take forever. So we want to be a little bit more efficient. So it's useful to have an equation for the sequence because we can find the value of any term in a sequence quickly. Okay, so if we wanted to find the 32nd term, I'm going to use the equation that we wrote. And I'll sub into both equations so you can see. So here's the equation a sub n equals negative 6n plus 4. And here's the equation a sub n equals negative 2 plus n minus 1 times negative 6. They're really both the same equation. One is multiplied out and one is not. So if I wanted to find the 32nd term, what I'm doing is I'm plugging a 32 anywhere I see an n. Okay, so here I would have a sub 32, that means my 32nd term is equal to negative 6 times 32 plus 4. So now I have to figure that out. So I'm going to go to my calculator and say, okay, negative 6 times 32, that's a negative 192. And if I add 4 to it, I get negative 188. So my 32nd term in the sequence is negative 188. If I had plugged into my other equation, it should have given me the same answer. So negative 2 plus 31 times negative 6. So negative 2 plus 31 times negative 6, negative 186. And that equals negative 188. So you didn't have to do it both ways, but I just wanted to show it to you both ways. Let's take a look at example 2. What is the formula for the nth term of the sequence shown below? So the first thing you have to figure out, is it an adding pattern or is it a multiplying pattern? So if I'm looking to go from 10 to 12 and 12 to 14 and 14 to 16, you should see that there's a common difference, and it's a common difference of 2. So if there's a common difference of 2, that means it's an arithmetic sequence because there's an adding pattern. So to write my equation, usually I use the letter a sub n equals a sub 1 plus n minus 1 times d. But in this case, you'll see my equation is equal to b. And if you look at all your choices, they're all written in terms of a b. So I'm going to rewrite my equation. I'm going to say, okay, you know what? I'm going to use the letter b. So b sub n equals b sub 1 plus n minus 1 times d. Okay, so now I need to find the value of my first term. So I'll go to my equation, say, okay, my first term value there is a 10. So the 10 is going to be replacing the b sub 1. So this should be a 10. Okay, plus n minus 1. Now I need my common difference. So we said to go from one term to the next that our common difference was a plus 2. Right? To go from 10 to 12, we added 2, then 12 to 14, we added 2, and 14 to 16, we added 2. So this is going to be a 2. Now, if you look at your choices, you'll see that 10 plus n minus 1 times 2 is not there. So what that means is you are going to have to multiply this out. So 10, it's going to rewrite it, plus n minus 1 times 2. It's a little strange because you're multiplying backwards. It's not really natural, but you'll get used to it. So 2 times n is 2n, and then 2 times negative 1 is negative 2. And then I can combine my like terms. So I would have 2n plus 8. So b sub n should be equal to 2n plus 8. And that's really equivalent to 8 plus 2n according to the commutative property, right? You could change the order of two terms that are being added together and they would still be equal. So we got this. That's the same thing. Okay, let's take a look at the last example, number 3. So they tell me the fourth term in an arithmetic sequence is 8. So I'm just going to write that down. I'm going to use the letter A for this one since they didn't tell me I had to use a different letter. Fourth term is 8, and the sixth term, my sixth term is 16. So I need to write an equation for the nth term of the sequence. So I'm just going to kind of write it out. So my first term, second term, third term. I know my fourth term is 8. This is my fourth term. And then I have my fifth term, and I know my sixth term is 16. Okay. So now I need to figure out the common difference. So there are two ways to do this. The first is to kind of just look at it and say, okay, well, I know that the common difference would have to be added twice here to get to 16, right? So let's see. So I would have to add 8 plus something would give me this fifth term, and then that fifth term plus something would give me my last term. So one thing I could do is kind of think about it. Well, how do I get from 8 to 16? Well, I would have to add 8, right? 8 plus 8 is 16, but I have to add a number, the same number twice. So I couldn't add 8 plus 8 because that would be too big. So my common difference would be a 4, right? Because 8 plus 4 is 12, and then 12 plus 4 would be 16. So sometimes you can kind of just look at it and figure it out. The other way would be to set up an equation. So you could say, okay, well, I started with 8. 8 was my fourth term. How many times did I add my common difference? Well, I added my common difference once, and then I added my common difference twice. So I added d really 2 times. So 8 plus 2 d's has to give me 16. If I solve this equation, I would get that my common difference would have to be a 4. Again, you don't have to show that work. If you can think about it in your head and figure out that's a 4, that's fine. So now we know our common difference, but now we run into another problem because we want to write our equation a sub n equals a sub 1 plus n minus 1 times d, but we don't have all the information. So I know my d value, I just found that, had to be a 4. But I don't know my first term, so I'm going to have to work backwards. I'm going to say, okay, well, if going forward I was adding 4 to get from 8 to 12 and 12 to 16, I want to go backwards now. So I'm going to subtract 4. So 8 minus 4 would give me a 4. Then 4 minus 4 would give me a 0. And 0 minus 4 would give me a negative 4. So my first term should be negative 4. And now if I thought about it, if I wanted to check it, it would follow the pattern. If I started with negative 4 and I added 4, I should get 0. Right, so if I followed my pattern now, I would say, okay, negative 4. If I was going forward this way, plus 4 would give me 0, 0, plus 4 would give me 4, 4, plus 4 would give me 8, 8, plus 4 would give me 12, and 12 plus 4 would give me 16. So I could really just check myself once I work backwards to find my first term. So now I'm going to finish up writing my equation. I know my first term is negative 4. and I know my common difference is a 4. So I could write my equation for the nth term like that. So that would be one way to express my answer. Or if I wanted to, I could multiply it out. It's really up to you. The only time you have to multiply it out is if you're looking at a multiple choice. So if I'm multiplying out, I'm multiplying the 4 by the n and the 4 by the negative 1. So a sub n equals negative 4 plus 4n minus 4. I can combine my like terms and I can say, okay, a sub n equals 4n minus 8. So you could write your answer either way. After the notes for today, you should see a practice section. There are 7 questions, and in each question, they ask you to find the common difference. In other words, how much you're adding to get from one term to the next in a sequence. This is the first thing you're going to find. The next thing you're going to find is the first term in your sequence. And then write an equation for the nth term. And lastly, you want to plug in the number 10. So once you write your equation, you're going to replace your n value with a 10. So please pause the video and answer these 7 questions. Okay, so let's take a look at these and go over them. If you look at question number 1, you have your first sequence. Your common difference is a 3. So you're adding 3 to get from 1 to 4, or 4 to 7, or 7 to 10. So my common difference is a 3. My first term is a 1. So to write my equation, I have a sub n equals a sub 1, which is a 1, plus n minus 1 times my common difference of a 3. And if you want to, you can multiply it out, but you don't have to. For the last part, you want to plug in a 10 for n. So a sub 10 equals 1 plus 10 minus 1 times 3. And here we actually want to calculate the value. So we have 1 plus 9 times 3. So 9 times 3 is 27, plus 1 is 28. So my 10th term value in this sequence is 28. So if I kept that sequence going out to the 10th term, I would get 28 as my 10th term. Okay, let's take a look at number 2. So for number 2, you want to think about what are you adding from 2 to get to 8? So that would be a 6. And you can test it. Is 8 plus 6 14? It is. Is 14 plus 6 20? It is. So my common difference is a 6. Now I want to find my first term. So the value of my first term is a 2. So now I can write my equation. A sub n equals the value of my first term, 2, plus n minus 1 times d. And again, you can leave it like that or multiply it out. And the last part is just asking you to plug in 10 for where you see an n. So the value of the 10th term in this sequence would be 2 plus 9 times 6, which is 54. So 2 plus 54 is 56. So the value of the 10th term in my sequence would be 56. Okay, let's take a look at number 3. This one's a little tricky. So I want to think about what would I have to add to 18 to get to 14? So notice 18 is bigger than 14. So really you're adding a negative. So I would have to add a negative 4. And I could test that. Is 14 plus negative 4 10? Yes. Is 10 plus negative 4 6? Yes. Okay, so my common difference is a negative 4. My first term is an 18. And now I want to write my equation. So a sub n equals the value of my first term plus n minus 1 times d. And now lastly, I'm asked for the value of the 10th term. So 18 plus 10 minus 1 times negative 4. So if I calculate that, I have 18 plus 9 times negative 4. 9 times negative 4 is negative 36. So I have 18 minus 36, which is negative 18. Okay, let's take a look at number 4. So I want to think, what would I have to add to -4 to get to -1? So I would have to add 3. Same thing here. Same thing here. So my common difference is a 3. My first term value is a -4. And now I can write my equation. A sub n equals -4 plus n minus 1 times 3. And now I want to find the value of my 10th term. So to find my 10th term, it's -4 plus 10 minus 1 times, oops, it's not letting me put that parenthesis there, times 3. So -4 plus 9 times 3. So 9 times 3 is 27. So -4 plus 27 is 23. So my 10th term would be 23. Okay, let's take a look at number 5. So the common difference for number 5 should be 0.3. If you had trouble figuring that out, remember, you could always set up a little equation. 0.1 plus something equals 0.4. And if you solve that equation, you would get 0.3 or 3/10. So your common difference is 3/10. Your first term is 1/10 or 0.1. So to write my equation, I have a sub n equals my first term plus n minus 1 times my common difference. Okay, now I want to find the value of my 10th term. So 0.1 plus 10 minus 1 times 0.3. So 0.1 plus 9 times 0.3. So I could type it into my calculator if I wanted. 0.1 plus 9 times 0.3 is 2.7. So my 10th term is 2.8. Okay, let's take a look at number 6. I'm adding 2 to get from one term to the next, so my common difference is plus 2. My first term is a 9, and I can write my equation. A sub n equals a sub 1 plus n minus 1 times d. Now to find the 10th term, I plug in a 10 for n. Let's see. My 10th term is 9 plus 9 times 2. So 9 plus 18, which is 27. And lastly, I want to find the common difference here. So -0.8 plus what would give me -1. So I'd be really adding a -0.2. But again, you could, if you weren't sure, you could set up your equation. -0.8 plus something equals -1. And if you solved that by adding 0.8 to both sides, you would get -0.2. So my common difference is -0.2. My first term is -0.8. So I can write my last equation. A sub n equals my value of my first term plus n minus 1 times d. And now I want to find the value of my 10th term. So -0.8 plus 10 minus 1 times -0.2. So I have -0.8 plus 9 times -0.2. So if you want, you can go to your calculator for this one, or you would know this is -1.8. And now I'm going to add -0.8 and -1.8. And I'm going to get -2.6.